Okay, so on page, it's 165 in mine, you have a page that looks like this. I can't go above because I've just taken out the pages for me to be able to write in them. Now, we will do this experiment when we go back. So if you want to leave this gap here for your own results to go in, you can, and I will put the example on a piece of paper for you. So none of the maths is weird. There is just this conversion at the end where we have to put it into parts per million. So I'm going to give you the data. Do you think you would like to try doing the maths yourself, or do you want an example? So I can see all of the heads.
Example.
Example. Okay, we go example. So you should always, from your information in your question, make your table of stuff. So we have V, we have moles per litre, and we have N, which is our ratio. And the ratio for this is always going to be a 1:1, and we said it's going to be that funny equation. It'll always be given, but it's always 1:1. So we had 10 centimetre cubed of water, we have 6, and we have 0.01 moles per litre of EDTA. So this is a rubbish titration because our volumes are really, really low. Because I couldn't find water that would actually work for us. So this is last year's data. So as such, this would be rubbish. You'd need a better water sample than this. This is missing, so this is the way in. And I remind you about the funny W. So in the funny W, we start off at big M. We do a division coming down to bring us to moles per centimetre cubed. We do a multiplication on the way up to give us moles at tighter volume. Okay, and it's divided in two because this is our EDTA side in this example, and this would be our water side. So we're using our ratio here. We then have to do, so every time you go down, it's a division, and we'll get moles per centimetre cubed over here of our water. And every time we go up, we do a multiplication, and this brings us back up to our moles per litre, in this case of our calcium carbonate. But this is the data for the water side, this is the data for the EDTA. So by the time we get to this point in the middle, we will have used all three of these numbers. And then on the opposite side, we use the ratio, and we use the 10, and we finally find out what this is. So the first step that I always start with is, what does this tell me? You don't have to put this in, I just do for completeness. So this is in moles per litre. So the thing I have to do is I have to convert this into moles per centimetres cubed. So I'm going to divide it by 1,000 to do that, and I'm going to get 1 by 10 to the 1, 2, 3, 4, 5, by 10 to the minus 5 moles in a centimetre cubed. Now, I personally would do all of the maths first before I'd ever look at the question, because you're going to have to do it anyway. And we've said, depending on how they asked it, if you don't know to annotate, don't annotate anything. Make it so up here in the page 165, it says parts 1 to IV. If you don't know what thing that you should mark, then when you start your maths, you just go 1 to V up here if you don't know to annotate. And you take your punt. So once we've done that, I need to find out what's in my titer volume. So I am going to multiply that by 6, and that's going to give me, am I out of decimal place? 0.01 divided by 1,000. No, I'm right. Is going to be 6 by 10 to the minus 5 moles. And this is in 6 centimetres cubed, and this is our titer volume. So I'm now up at this flat part of my W. So here I use my ratio. The ratio is 1:1, so that implies I must have 6 by 10 to the 5 moles of the calcium carbonate in 10 centimetres cubed of water. So this is my other titer volume. It then asks me to, in my W over here, I am at this point now. At the W, I want to find out moles per centimeters cubed. So I 6 by 10 to the minus 5 divided by 1,000. Divided by 1,000 is going to give me 6 by 10 to the minus 8 moles in 1 centimeter cubed. And then I'm going up at the last bit of my W, multiplying by 1,000 to give you 6 by 10 to 1, 2, 3, 4 minus 5 big M.
Miss?
Yes.
For those last two steps, why do you have to like divide by 1,000 and then multiply by 1,000?
Because, oh, thanking you. Good spot. I was wondering why this was so big. So it should be 10 to, so 6 exponential minus 5 divided by 10. Good spot, Roisin, good spot. So 6 by 10 to the 2, 4 to the minus 6. And then multiply that by 1,000. And now it should be 0.006 big M. Okay, apologies. Now, can I just show you fourth triangle when we do it? The fourth triangle is the one that where moles is on the top. And it is C, so concentration in moles per liter, by V over 1,000. Okay, so in the first part up here, when I wanted to find out what was my moles in 6 centimeters cubed, I could put in 0.01 multiplied by 6 over 1,000, and that will give me this answer. So it's a real shortcut way. You could do it, and conversely, when we have the second half of the W, so now we do have moles. We have 6 by 10 to the minus 5. We don't have the concentration as the question mark, and we have the volume of 10 over 1,000. If you actually put that into your calculator as a fraction and a fraction, so you literally put it in as it stands, it will do this for you. In reality, in real person maths, what it does is this flips. So if you look at what we do, we divide by 10. There's our divide by 10. We multiply 1,000, multiply by 1,000. But if you input this into your calculator as do your fraction, put a fraction under the line again and plug it in, it will do this flip for you, and it will give you this answer. So you can use fourth triangle if your life sucks and you really can't follow the W. But you just have to make sure that you are answering the question that they have asked. So usually we always do moles per litre, and usually we always turn it into grams per litre. I need to do that. Excuse me for a second. This deleted a whole load of stuff that I didn't want it to do. I don't understand why. Okay, I think that is us where we want to be. So in this one, the grams per litre, we're converting it into calcium carbonate. So you would do your little calcium carbonate, CaCO3. So calcium is 40 by 1, it is 12 by 1, and it is 16 by 3, and that gives us 106. So I would multiply this by 106 to turn that into, 100, to turn that into 60.06 grams per litre, and that's usually where we finish our maths. But I'm just going to go up to the top, and here it asks you, so we have done all of these and we'll go back and annotate them in a second, but it's the last bit, if we have to convert to parts per million, and that's still a skill that you are going to have to do even if this water hardness doesn't turn up. So milligrams will always be a bigger number than grams, so you are multiplying by 1,000 essentially. To turn 0.6 into milligrams per litre, you would multiply by 1,000, because there is 1,000 milligrams in 1 gram, and that will get you to 60 mgs per litre.
Miss.
Yep.
When you divide 0.006 by 100, why do you put, what's the...
It's not, no, it's not dividing. That's not a dividing. This was pointing at something else. So this is a multiplication. So usually when we have done our maths, the maths things that are always in every question is moles per litre and then grams per litre. They're always two things that you definitely will have to have in there. And if you now just look at what it says on page 166, it asked you the moles of EDTA required at end point. That is here. So this would be the answer to part I. It asks you the moles of your metal ion that's reacted in the water at the end point. So that is this part, because that's going to be your calcium carbonate. So that was 2 if you're annotating it. The moles per litre of calcium and magnesium ions is this part. It then asks you the total hardness of water in grams per litre expressed as calcium carbonate. That is this, IV, and then it asks the total hardness in parts per million as calcium carbonate, which is this part down here at the end. So you're either annotating it like this once you've gone through it. I wouldn't even rewrite it out again, as in I wouldn't write out part I, give an answer, part II, give an answer, because that's wasting your time, and you could screw up in the transcribing. So keep it as simple, do it once, just make sure obviously your maths is correct, and you go from there. Any questions? Okay, so this is the 2018 question. I am going to leave you to do that now. I think we have all our numbers. Yep, you have everything you need. The QR code is over it. So somebody somewhere has done this as a full question. For you, I think it's only the maths that's done. Maybe it's not, maybe it's a full question. But you have that QR code. So you're going to do the 2018. You'll see in your book there's a 2018, a 2010 and a 2004. So we get as many of them done as we can now. And there's a page in OneNote going to ping at 2 o'clock. OneNote is very slow today, or Teams is slow today, for you to put up if you want feedback. Okay, have your moan now. What's up?
It fell on the ice.
Oh, well, that's what's going to happen. Okay, Mum is teaching now, my sweets, so you are going to need to go somewhere else. Or be super quiet. I'm on mute now for you.
Okay, I'll go.
Okay.
I'm taking this hat.
Brilliant.
See, it's stylish.
Stylish. Okay, I'm going to start putting it up, and you can shout if you issues. If you're waiting and you're done, you can move on to the 2010.
Miss.
Yeah.
When you're finding the moles of M2 plus that are in the water, why don't you divide by? Why do you just use the molar mass of magnesium? Why don't you? Or wait, is M? What does? Is it Mg or what is the M?
So remember we said this is total hardness, and total hardness is looking for both calcium and magnesium ions. So the M is just a general M, and M just means metal in the equation, but you're testing both calcium and magnesium ions in there, or both of them are reacting, and we're expressing this result as calcium carbonate. So
Okay.
the M is just giving you the ratio, and in the results down here, when we're multiplying it by 100, that's the molar mass of calcium carbonate, because it's told you in the question, total hardness of water expressed in terms of calcium carbonate. So
then when you're dividing by 50,
that's by 50 centimeters cubed of water, which contains a certain amount of the metal. This amount.
Oh, so it's 9.3 by 10 to the minus 5 moles of metal in 50 cubic centimeters of water.
Correct. And we just haven't put any name of the metal on it just yet. And when we get down to this point down here, we are now expressing it as calcium carbonate.
Oh, yeah.
When we multiply the 100 is the molar mass down here at the bottom left of calcium carbonate.
Okay, thank you.
You're welcome.
You see, in 2010,
yeah,
it says there's 9.2 centimeters cubed of 0.1 molar EDTA,
yeah.
0.01. But then afterwards it says, after ion exchange required an average 2.4 centimeters cubed. What's that?
Okay, so what they've done here is, so I'm just going to move this to here. So what they have done is they have taken their water sample, so they have their first sample, and they've tested that, and then they put it through an ion exchanger, so that's to remove hardness. So they put the sample through the ion exchange and it comes out at the bottom, and you now have a lower amount of EDTA required because the water is now less hard. So you can see here there's a question, repeat these calculations for water after ion exchange. So you had to do 2 sets of maths.
And one you used the 9.2 and one you used the 2.4.
So the 9.2 is the sample 1, and then this is your ion exchanger, and you got now a sample, and you've removed some of the hardness. You haven't removed all of it, so your ion exchanger is crap, but that's where you're at. Okay, I'll put up the first half of that question in a second now. So it asks moles of EDTA at endpoint. So that's the first half of the 2010 calculation if you're doing it. Put the second one out. Are you ready for the second half of 2010 or? Yeah. Then you just have 2004 left.
Miss, why do you multiply by 100 to get the grams per litre if grams is mass by molar mass?
So let me go up to it. So we're on the first half of the second half. The second half.
Yeah.
So your triangle is, you have moles, which is the 4.8 by 10 to the minus 4. You're multiplying it by the molar mass, and the question is telling you that it's the molar mass of calcium carbonate is what you're expressing it as, and this 100 is the molar mass of calcium carbonate. So I'm going from moles per litre to grams per litre. So I will show you the last question now. Okay, is it okay if I change the screen?
Yeah.
So this is the last question. So they're the maths for that. So the assignment is pinged already. It has pages for these questions. I would just like you to go and look at those 4 questions and do the other parts to the question, because this is now your titration practice. How do you clean pipettes, burettes? How do you use them? What are the steps for accuracy? So that's all practicing for that. On the assignment post, so in our general post where it pings where the assignment is, I will put in the link for the video for what's called biochemical oxygen demand, and make sure you have a look at that for tomorrow. So again, it's probably unlikely that they are going to ask you, it's not going to be water this year, but the BOD uses, they can ask you the theory of it in the long questions outside of section A, and more importantly it uses redox, so there's a repeat theory again for us to go over tomorrow. Any questions? How was the maths? Yes, thank you for the thumbs up, Roisin. Good to see. Thank you very much, Sam. Thank you, Cam. Okay, so I will add the link